Hey everyone, my name is Isaac, and today I'm going to be talking about AI search optimization for developers. So, we're going to be with a video game theme today, and hopefully, our agenda today is going to start with character creation. Then, we're going to move on to story mode and talk about the history of how finding things online has worked. Then, we'll move on to the boss fight and talk about how we can keep our projects visible and relevant in the age of AI. And then we'll end with the open world where everyone can move about at your own pace and ask me questions, and I'll do my best to answer. So, starting with character creation, we got player one, which is me, player two, which is the JS group, all of you. And then there's two other players here. There's the internet users who we're trying to get our projects out in front of, and then there are the AI overlords. Okay, so me, I'm Isaac. I am the co founder of a writing agency called Content Cucumber, and we recently merged with another growth driven agency called Content Basis. And between these two companies, we basically help companies do all sorts of marketing projects, from creating blogs and videos and content to improving their websites and just generally helping companies do better work online. So that's me. And one more fun fact about me is that I'm a street performer in Chicago also. I play music at big events. So if you're ever at the Cubs or a big concert or a parade, you might see me out and about playing guitar. Okay, player two is the ChicagoJS group, and I just wanted to make a quick point about how this is, relevant to a group of developers, because usually I'm presenting this kind of stuff to maybe, people who are launching businesses. And one thing, obviously, is as a developer, you might be, in kind of an entrepreneurial role, selling your products or even just your own services to companies as a freelancer. And in that case, having a good website is super important, and just generally, having good principles about AI development and making sure that your site's findable is super important. And yeah, if you build websites, obviously this is going to be very relevant. Okay, two more characters real quick before we start. We have the internet users, which is basically the people who we're trying to get out in front of when we're building websites or, just implementing the things that I'm going to talk about here. And then lastly, we have AI. And so the whole idea that we're going to be talking about here is, SEO, I think, is pretty well known and famous at this point. All the best practices you can do to make sure that your website stays visible to people who are looking for relevant things online. And more and more, as we'll talk about soon, people are, foregoing using something like Google and are instead searching for things with AI. So the question we're going to be answering is how to make sure that your company, your website, whatever you're building, is used as a citation when people are searching for relevant things with AI, or used in the training data so that your, ideas and perspectives have the ability to get out in front of people the same way that, you're probably familiar with doing for search engines. Okay, so before we go to the next stage, which is going to be story mode, I wanted to just do a quick poll and see kind of how the adoption of AI search is going among the crowd here. So if you want to participate, please scan the QR code and it'll take you to a poll about how often you're using something like ChatGPT or another LLM instead of, say, Google, or maybe Bing if you're a Bing user.
How many people use Bing?
I guess that could be another poll. Yeah. I think something like 5 to 10% of users. Give everyone just a minute, and then I'm going to have to exit my slide to see the answers.
That question would be for what? Looking at facts or looking up what is it? What are you searching for?
Right. So I think where it really does the best to search for things with, say, ChatGPT instead of Google is when you're looking for a really specific use case. So one time where I think the thing that caused me to start adopting and started me to start using ChatGPT sometimes instead of Google was when I bought this computer. And I basically, I had kind of a list of things that I wanted. What's a good computer for like light music production, what's a good computer for video editing, what's something that's really lightweight and easy to move around since I'm often on the go, and maybe 12 different things like that, which with Google, you might have to look up at least a few of those separately into individual articles and bounce around between different websites, not even to mention like weighing how one might affect the other. Like if it's lightweight, its battery weight and lifetime might not be as long. So um, I think that when you have like a whole lot of parameters and you want a custom answer that's exactly written for your use case, it can be super helpful. One problem that we'll talk about later is that it can hallucinate or just make mistakes. So that is a very serious downside, but that's, the number one place where I've found it can be really helpful to use AI instead of, Google. Now, on the other hand, for like a super factual question about like the news yesterday, I would definitely go with Google. But yeah, I mean, as we can see from these results here, definitely more and more people are kind of on this page of using LLM instead of Google for a lot of things. So that's definitely the trend that I've seen in my job as a writer for companies who, pretty much the whole reason they're hiring our services as a writing company is to get blogs that show up for people. And more and more those are, people aren't directly clicking to them. Maybe those blogs are being cited and your recommendations are being put out there or you're being linked, but it's definitely a different game compared to Google. We're going to go into story mode real quick and basically just talk about how we got to where we are. And we're going to start with the BG before Google and then move on to the age of Google and then talk about a post-Google landscape that's starting to emerge. So before Google, if anyone remembers those times, there were a few different options to find what you were looking for. In the earliest days, you kind of just had to know what you were looking for and, maybe, pass websites around by word of mouth or by memory or by bookmarking them. Then we went on to directories where, essentially like yellow page type websites that had lots of different links for where you could go. And Yahoo became the leader and just did that better than anyone ever did. And for a while, they were like the most popular place to start your internet browsing experience because they did that kind of directory-ish model better than anyone. But very quickly, like once search engines became better and had capabilities beyond that, like Yahoo went away pretty quickly and is now like kind of obscure. And the only time I ever end up on Yahoo myself is if I install the wrong extension on Chrome or something that makes Yahoo my default browser. So, I don't know if anything that drastic is going to happen to Google, but I don't think anyone thought something that drastic was going to happen to Yahoo at the time either. But I guess before Google really emerged as the clear leader of all that, new search engine model, there were a bunch of other ones like Ask Jeeves. And I think the main reason why Google did so much better than any of those other companies is that Google had just the best ability to parse out what was actually the best answer for your questions. So like these earliest models, you could just put the keyword that you wanted to rank for like in white text at the bottom of your page like 100 times. And if you just say the word pizza more than anyone else, you might be the one who came up when someone searched for pizza. And they slowly became more sophisticated, but Google just took things to a new level by doing things like, weighing who was linking to you and how reliable they were, just to name like one example, which just gave infinitely better results than judging on how often you were using a keyword or other more simplistic methods. So to give an overview really quickly of just some of the factors that Google uses, you might have things like how well your site's structured, how people are behaving once they land on your site. So people spending a long time dwelling on the website, it's a sign that maybe they found what they were looking for. Whereas if someone bounces away immediately, that's a sign they didn't find what they were looking for. And it's basically studying each and every one of those through what's also AI and just, finding with each and every search that people make better and better answers to those types of questions. And yeah, I mean, it was, as far as search engines goes, it was obviously the gold standard. And, with those couple of Bing users aside, most people settled on Google. And every single year for like over a decade, Google would be a larger and larger percentage of search traffic until last year. And last year, for the first time ever, Google started losing search share and is now less than 90% of, when people go online to look for something, they're using Google less than ever. And yeah, a lot of people think that's probably going to continue. AI is probably only going to get better. And Google even has kind of, like, you could say, shot themselves in the foot or tried to adapt. But like you've probably noticed, they're pushing their own AI, which is, I would say, not even as good as like ChatGPT. So, I think they even see the writing on the wall as to where things are going. And yeah, on this slide, I was going to talk just a little bit about kind of what the pros and cons are. So, as far as what's driving people to adopt AI tools, we have higher levels of customization. Like I said, if you want to put 20 different parameters and get your own custom article written back to answer your question, that's a huge advantage. Also, that it's conversational. So like if I put in all those different things I wanted out of my computer, my first message, and then wanted to say in the second message, oh wait, and also I want to spend less than $1,000, what's the best option that hits that budget? It can like conversationally respond to me. And then the last factor, which is kind of silly when you think about it, but it literally is just that you don't have to click to another site and go find your answer after you ask your question. So, there's like the stereotype or the joke of like going to a recipe and they tell you like 30-minute story about how their grandmother invented this pasta sauce or whatever, and ChatGPT will just tell you, the answer unless you ask it to invent a story about a pasta sauce. Do that too. But yeah, the cons are hallucinations, which is that they can just kind of make things up. Then you have the sourcing, which they will give citations, and it's becoming a more and more valuable thing to be cited in a OpenAI answer as the source. But at the end of the day, you don't always know. It could be pulling stuff from like Joe's blog, or it could be making stuff up or getting confused too. And then lastly, there's just ethical concerns around it, like, mistakes that can be made from that, or just the way that it's taking data and everything. So that is causing some people to resist it. But I think, at the end of the day, like, it didn't really slow down Google or, any of these tech companies are all kind of playing the same game. And I think they're all going to be, highlighting these kinds of AI searches more and more. So anyway, with story mode out of the way and kind of laying the foundation for where we are and why AI discoverability matters, I want to talk about what you can do when you're building, say, a website to make sure that your site actually is being fed into OpenAI so that you can be cited, or so that you can be found when people are searching with these new kinds of methods, because, it might go from 10 to 50% of searches being with AI in the near future. Just understanding kind of what you can do to be visible is going to be pretty valuable. So part of what plays into showing up on AI systems is going to be the same sort of stuff that you would do to be visible to a search engine. Like creating unique content is going to be really important. So is acquiring backlinks from good sites and using a clear structure in your articles or your pages and having fast site speed. But on the flip side of that, there are some things that are unique to how AI bots are crawling and indexing and understanding information that's on the web. So for one, like having an exact keyword phrase is not as important. Something that in my writing company we get asked to do kind of frequently is, say, like we're writing for a plumber to come in and kind of answer the same question in 10 different ways that 10 different families might be trying to search for the same thing, and give them, answers that will show up based on that search. And AI does have a better ability to kind of parse through, understand the meaning, and not rely on having the same thing explained in a bunch of different ways. Same thing with backlinks. So one of the real quality factors that made Google awesome is that, say, a link from the New York Times is going to count way more than a link from, maybe a small online like blogger. And with AI, they do have certain sites are marked as high authority, but overall that system is less sophisticated, and it seems backlinks are less valuable in terms of ranking and getting seen on those systems. But on the flip side of that, using structured data in your website development is more important for AI and more valuable in terms of getting you, seen and making sure your content's indexed. And then fast rendering is also more important because Google is very patient and very thorough with how it crawls and understands what's on websites, whereas these AI models don't stick around. So like if your site renders really slowly, Google will like stick it out and figure out what's on there and index it, whereas ChatGPT won't. And that's where we get into some more like specifically coding and developer type topics. So like I said, structured data is one of the most important things you can do to just make your content understandable to LLM like ChatGPT. And the most basic form of that is just making sure that you're using like headers and bulleted text and structuring it in a way that is also good for humans because it's very scannable, but is makes it easier for these kinds of things to parse. And then one level on top of that is also using like microdata, or better yet, JSON LD markups. So tagging your articles as articles, your products as products, your FAQs as FAQs. As smart as LLMs can sometimes seem when you're talking to ChatGPT, they do also rely on things like this a lot when it comes to indexing and understanding what's on your website. So when you're building websites or working on client websites or whatever the case might be, it's a great idea to use these kinds of tags. And there are a couple ways of doing it. So here we have a couple of FAQs that are just no markup whatsoever, just plain HTML and what that would look like. And here it is if we add microdata tags into the text. So yeah, basically you can see we've added these schema.org tags, and we just kind of say like this is an FAQ. And again, that's like surprisingly important to helping like ChatGPT parse through what you're actually saying in your FAQs. So especially if you have a product that's very unique or very differentiated from your competitors, and you want people to be able to find and identify that through talking to ChatGPT, it's really valuable to do this. And as you might have noticed in the example I gave, it is like in those kinds of shopping or looking for very specific solutions to problems that AI can actually be very valuable, which is why like a lot of e-commerce companies are looking for people to basically mark up these sites with what you can see is pretty simple code. And then there's a better way to do this same thing, which is with JSON LD. And basically the way this works is instead of mixing these tags right into the HTML that you're doing, you can basically add a script in the header of your page that tags all of the same things, but separately, so that if you want to come make changes later, it's a lot easier and your code is cleaner and simpler. Okay, and one last thing that is a big technical fix that will help websites be better understood and ranked, I guess, by AI systems is making sure that they render in a way that an impatient system like ChatGPT can handle. So, whatever you might think from an aesthetic perspective, for example, static kinds of websites are going to be the easiest for something like ChatGPT to understand and index and use as its training data. Whereas something that's like, say, API only, like a table that dynamically fills based on data that you're managing internally, is going to be very hard for something like OpenAI to understand and read. So if you're using, that kind of example of like an API filled table, it's good to have at least information around on the rest of the site that is more like readable in the sense of being something that's static, or in the sense of something that you've taken measures to kind of help the rendering happen faster. So if you're using something like React, for example, it's good to pair that with Next.js so that you have like a static version rendered immediately, and then it can, you can add the fancy stuff later. But the key is getting like immediately a version that something crawling your site can understand. And that's pretty much what I have. So again, I think a lot of the basic concepts of SEO still apply, in the sense that if you want your website and your ideas to spread, creating a lot of content around them is the best way to make them visible on the internet. But then, as we've seen, these like relatively simple tech fixes, like adding the structured data and making sure that websites render really quickly, is super important for visibility. It's something that a lot of e-commerce stores and websites that sell things online care about a lot. So it's definitely something worth learning about and understanding if you're, building your own website, or building a site to promote something that that you built, or, maybe looking for opportunities to work with companies in a way that helps them grow.
We've gotten really excited about this A1 stuff that's going on. I'm sure you've heard about it, like every talk, because all I hear is about A1, right? Yeah, it's good on steaks, I hear. So like everybody else, I'm jumping on that bandwagon. So some of you might have seen Microsoft maybe like a couple weeks ago. They introduced these smart components. Let me show what those look like. This smart components from .NET. They released 3 of them. The first one can take unstructured data, and it's a smart paste. You can just paste this into a form, and it'll try to fill out your form for you. The next one kind of like an autocomplete as you're typing, type ahead. Just add it. And then the final one is a smart combo box, which, depending on what you type, can figure out the most related options in your list. And I thought this was brilliant. This got me really excited, so that you could just drop in a component pretty much and improve your user experience like that, right? That's so cool. But I'm not a .NET person. Who is .NET here? Just wondering. Oh, the fortunate souls get this. People doing Blazor or Razor? Any
Blazor.
Blazor? There's a Razor too, right?
Yeah.
What's the difference?
Blazers for the face, blazers like for
Okay. Good to know. So what I was looking for is a component that you can pretty much drop into any page, and of course, use with JavaScript. So we got to work building the first one. So I'm going to show a little demo of it. By the first one, I mean the paste, smart paste. So this is our demo. You can copy, and there's a little paste. You click, and it will fill out the form for you.
Whoa!
Wow, yeah, isn't that fun, right? Like I love the idea of just add the component, and it figures out your page and can work with AI. That's amazing. Really smart idea from Microsoft. So we released this. This is a if you're interested in using it, there's a QR code, but it's just a normal web component. It does require a service to talk to the API. If you're using Node, we released a little. I'll actually just show the use, what it looks like. You just import this native web component, drop it into your page, tell it where to go for some API. It will grab your form contents and whatever's pasted and make a request here. And then you can just handle the request and call another exported function that we produce, extract form data, and that will give the JSON result back that the smart paste component can use to fill out your form. It's as simple as that. It works by reading the clipboard text. We're going to change that also so it, if someone doesn't want to allow sharing from the clipboard, you can put a little text box there and they can just paste it. It still works. Scrapes those visible form fields, sends it to the endpoint like I mentioned. We're using the Vercel AI SDK. I don't know if anybody's used that yet. It's a wrapper for different models, so you can connect it to almost any model that the SDK supports, and then it just takes that data back from the AI and populates your form. So this is just the start. It doesn't handle all, it handles a lot of form controls, but not all of them yet, right? Like date picker, we don't have working quite yet. We want to make it easier to customize the provider, and then we're going to look to support all of the other Microsoft components and some ones that we think would be cool, like, paste a CSV and it can fill out the form and then hit return and then fill out the form again. So if someone's got, I worked in those situations, you have an Excel filled with like hundreds of records and you want them all created quickly. So maybe a component that can do that as well. So that's pretty much it. That's my presentation. The reason why I'm here though is how many people would, like, if these components existed that you could just drop in, would consider, using them on their web page or think that their UX designer would use them. Just want to see if it's worth us continuing to pursue this. Okay, some hands. Okay, so we're gonna drop this. Cool. That's the only.
The world was in our hands.
Yeah, sorry. It's market research, right? And if you were here 2 months ago when I did my other market research for another open source tool we're developing on Extractor, this is now a Figma plugin. This is the thing that can extract from Figma a bunch of CSS mix-ins. We just added Tailwind support because we're gonna start using it for one of our clients in a large design system. So excited about that. So if you have any questions about any of this, feel free to reach out to me or connect with me on LinkedIn. Thanks, everybody.
Just a little bit about me. As Heather said, my name is Shea Leslein. I graduated from Iowa State. I love the state of Iowa. I've been doing the full stack software development thing for a little over 20 years. I do have .NET experience. It's a little bit in the past, but I'll flex a little bit. Blazor is the server-side rendering stuff. They do some WASM things on that. And Razor is the rendering engine. So I was very happy to work when Razor first came out in like 2008. It was good. It was good stuff. Today, however, I work for Freewheel. I've been with the company for about 14 years. And I work now not in a full stack capacity, but in a front-end engineer building out a design system, component library, that sort of stuff. But today, I'm here to talk to you all about the timeless topic of testing. I say timeless for a couple reasons. Firstly, because I was looking over my notes preparing this and realized that some of the resources that I have that I'm going to share with you guys tonight have been around for a while and date back to like 2005. So, but it really shows the point that testing is timeless because we all care about quality software, and testing is the essential aspect that makes our software quality. However, I feel like a lot of times the direction that automated testing goes kind of looks a little bit like this. Who here's seen Office Space? So, it's like, yeah, Peter, I'm gonna need you to come in, and I'm gonna need you to get to 100% code coverage in the next 3 months. So go. You can come in on Saturdays. It's fine. Now, I realize this is a simplistic over characterization, and maybe it's not fair. Okay, it's definitely not fair, but it feels like that can be the approach that happens a little bit in software development when it comes to testing. Kind of a thing that oftentimes gets bolted on at the end. What I really find about code coverage specifically is that quickly leads us to a place of Goodhart's law if we're not careful. Just this notion that once a metric becomes the target, it ceases to become a good measure. It can come to undesirable results. One thing I've seen here, and I got an example for everybody. Have a look at this. Who knows what this does? Anyone got an answer, Josh?
From the code coverage to look at it. Right?
Yeah, exactly. Yeah, exactly. So it says, hey, we want code coverage for all of our packages, except, the auth module, except the billing module, except the core business logic, except our data repository, and then except any other list of meaningful business logic code that we have here. Before anybody asks, yes, I have seen this, and no, it is not good. We should not do this. I've simplified the code snippet to make it much, much shorter, and also to protect the identities of those who have violated the code page. My hope today is really to move us from a place of chasing after a metric to a place where we can take a purposeful and principled approach to how we approach automated testing. And I think that really starts with having a good definition. So from my perspective, what I think is the desired outcome for automated testing is that we want to ensure that we've got a high level of confidence when we ship our software that is doing what it expected. It may seem obvious, but myself included in teams I've been on, it's easy to lose sight of this fact when we're in the nitty-gritty parts of our day job, working on those complicated, gnarly bits of our code of what's really critical software, and we get distracted. And I think it's really great for teams to have a strong shared definition of, really what our desired outcome is. Our desired outcome isn't code coverage. Our desired outcome is that our software is working as we expect it to. So today I've got 4 principles to share with you, things that I've found on the teams I've worked on that have been really helpful to give us the confidence that the software we're shipping is doing well. So real quickly, the first one is just that our tests resemble how our software is actually used. Well-written tests are an essential form of documentation. Code coverage is a really great leading indicator for us to look at to reach that desired outcome, to be confident that our software is doing what we expect. And then the fourth and final one that we'll talk about is that we should spend time optimizing for the fastest possible developer feedback loop that we have. We'll break all of these down, and I'll include some helpful practices. But the first one, again, tests should resemble how our software is used. As many of you here, I'm a web developer, and I'm building web applications, websites that people use. What this tells me is that the tests that I write should reflect how the user is using the system. To be honest, this is really almost a copy and paste from something Kent C. Dodds, the creator of Testing Library, put on the Testing Library documentation. But it's something that really resonated with me as I work with my teams to build web applications. And that is, we need our tests to reflect we're building web applications, the user experience. We don't want our tests to test implementation details. Sometimes we need to, but most of the time we don't. From my experience, really only 2 things happen when we test those implementation details. First, we start testing things that the users don't actually test, which is a clear violation of this principle. And the second one is that it can lead to fragile tests. And that's the really, really painful one that we end up dealing with. This principle in a lot of ways is very just philosophical, but it should deeply inform how we write our tests. And from a practical perspective, it means when we're testing our web applications, we should be paying attention to how we're selecting and interacting with the elements that the user works with. So let me demonstrate this in some developer terms, starting off with some things to avoid. Over the years, I've seen a lot of tests written like this, where we've got, a document.query selector, and then goes to find a button, and does the CSS class selector. Avoid this. Don't search that way. It's obviously a clear violation of that principle because The user doesn't open their dev tools. They don't go and look for CSS class names. But beyond that, tests like this that can be really fragile when you write them. Who's been bit by a bug like this before in testing? Just Steve? Oh man. All right, you guys are awesome. This is great. Because so when the tests are written like this, it can be really, really fragile. Imagine that you want to change and switch from using your own CSS selector names to Tailwind. Well, all your tests just broke, especially with something like Tailwind. The whole imagine that you just misspelled a name that made it through a pull request, and now you want to go back and fix it. Test broke. Imagine that you just found a better name for it. Test broke. You know, it doesn't work well. You end up having to go this. You create extra pain for yourself, and it highlights the fact that CSS class names are an implementation detail that users themselves don't actually care about. That being said, that isn't to say that CSS doesn't play a role in the user experience, because it totally does. The visual styles do. However, there's better tooling out there for visual test regression that you can use. I'm not going to go into those today, but just know that if you need to test, like what colors your buttons are and the sizes and the dimensions, there's tools out there that you can run that will help you test stuff like that. But at the end of the day, CSS class names are really an implementation detail, and we don't want to test them. So let's have a look at another one. We moved from CSS class names to HTML attributes because, that's better than class names. At least then when we change our visual styles and we rename those things, our tests don't break, right? Except for data test names or data attributes are just another implementation detail of our UI. You got a question, Josh?
Should be submit button.
It's like incorrect.
It probably is. These are totally contrived, simple examples. They really are. But I think you see it where it's a data test ID that you're querying by. But it's another implementation detail. You run into the same case where you misspelled something in the data test attribute, you want to fix it, or your team comes up with another naming convention to use. All your tests break. Did the user experience change in any way? Probably not, but the tests break, and now you're back in the world of pain of going through and fixing all of these things. Sure, an LLM can probably clean these things up for us now pretty quickly, but why burn the earth for it when we can just come up with better ways? It's not 2017 anymore, and we don't really have to write our tests this way. In 2018, testing library was created. Who here's using testing library? If you're not using testing library, you're doing it wrong. That's my hot take. Out of the box, it provides matchers that solve both the fragility problem that we just talked about, and it also encourages you and nudges you and maybe even forces you into following the web platform standards and increases just out of the box usability and accessibility improvements for your users when you test this way. If we look at this, we can see here within the test itself, you can see a screen.getByRole button. And then that button, it's going to go, actually, testing library is going to go find a button where the text inside the button says sign up. And what will happen here is there's no special selectors for implementation details. It's literally the text inside of a button. And what are parts of the user experience? The fact that it's a button that they can click, and the actual text in it is not an implementation detail. That's a key part of the user experience. If this button gets renamed from sign up to submit, and we go and we fix the code for it, we should expect the test to fail there, because the user experience is actually changing, and we need to go and fix the test to take care of that.
What if there are multiple buttons called sign up?
If there's
multiple different courses to sign.
That sounds like a terrible user experience.
Yeah.
For example,
Maybe.
the international add this. You have the different languages, not only the English one, but multi languages.
Yeah,
You have a dialogue that's has cancel on it. You can have something that's on the page. And so,
yeah. Testing library provides a lot of these things that help us do it out of the box. Again, I'm not really going to go into details for it, but it provides it in there, and it provides honestly an amazing developer experience. I came to testing library for the developer experience, and this will probably break Kaz's heart. I still kind of just stay for the developer experience, but the accessibility features that come from it are really great. So yeah, Corey.
Does it work for end-to-end tests? Because I've used this for like integration tests, but I've never thought of using it for end-to-end tests. Does it work with like Playwright and that whole?
Yeah, so Playwright actually, when Playwright was first made, they went out of their way to adopt the API to, I believe, 100% specification coverage with the testing library matchers and API that testing library does. So you get those accessibility features out of the box. Yeah, again, these are just like really contrived examples that I just type myself by hand that are supposed to simulate like B-test or just tests. Those kinds of unit tests that we often write during the day. Yeah. So yeah, the developer experience is great. It gives us a way to write tests that test the user experience and not the implementation details, much less fragile tests. So again, if you're building for the web and doing tests and you're not using testing library, my hot take is you're doing it wrong. Moving on to principle number 2 is the notion that well-written tests are an essential form of documentation. All code is documentation. We read the code. What the code says it does, that's what it does. We get it. I think we all agree that in that sense, it's the source of truth, and that well-written code that's clear and concise is amazing. Completely agree. But this principle really relates back to the first one, and it's an extension of that in the sense that we want to embrace a mindset that the automated tests that we write confirm how our code actually works. Because I've gone through and I've reviewed that PR where code looks great, just reading the test through quickly, tests look pretty good, test pass. Then I go and I actually use the feature, and you have that argument that conversation with a fellow developer that it doesn't do what it's really supposed to do. And our test should reflect what our components are actually supposed to do. They should get us out of that mindset of, well, it works on my machine, or yeah, my code's clean and all the tests pass. Like if the tests pass, but they're wrong, it doesn't matter. What we really want is we want our tests to be essential documentation. It's a great training and learning resource for onboarding new people. And personally, I would say well-written tests are a gift to your future self when you're going through and working on features, because we all forget things. And if it's documented well, it's easy to read through them and be like, oh, that's it. But how do we do this? And one of the great resources I found many years ago are these 5 tests that every question should answer. They seem kind of self-explanatory, but what are you testing? What should it do? What is the output, the actual behavior? What is the expected output? And then how can you reproduce the tests? It seems very self-evident. I'll say I'm guilty of this myself, but it's easy to not thoughtfully answer these questions when you're writing your test code. And I've got some examples to prove it. I've done some of these. Again, contrived examples taken, simplified, and used to protect the identities of all of the terrible violators, including myself. So what are you testing? Here, imagine that we've got multiple modules in a directory, and we want to test them. So we put the test for that in a file called test.js, and then we write some tests for it that kind of look like these. But then the test outputs for each of the tests look exactly the same. Is this really helpful to us at the end of the day? Not really. Not really. Let's look at the next example. Question 2, what should it do? Here's another bad example. The output doesn't necessarily say what it does. Here we've got a little bit more description in the sense that, okay, we know we're testing the phone validator. We know that we're testing the mail validator, but it doesn't say what it's doing. Again, not super helpful. Moving along to questions 3 and 4 about, what is the actual and the expected output. Here's a little bit of a different example. Can anyone spot what the real problem with this test is? The test output looks like it's pretty good, but there's an underlying problem with this test.
It doesn't assert anything.
It doesn't assert anything. It doesn't. I can't count the number of PRs I've reviewed where I read through the test and I was like, whoa, test pass, that's great. It doesn't actually test anything. This particular test would pass so long as the mail validator doesn't throw an exception. So is it really helpful? Not really. Don't do this. I have to confess, some people have called me on this too. So it does happen, but it's a very valid thing. Keep your eye out for it, because when stuff like this slips into your test suite, it's giving you a false sense of confidence when you ship your software. And then finally, the 5th one is, how can the test be reproduced? And this is a case where I'm going to elaborate a little bit more on this, but it's a case where reading through the test code itself and the implementation of the test code should give you very clear instructions about what you're testing, how you're testing it, what those actual tangible outputs are. So let's look at a couple of practical things that we have here that I've come up with. One is to just start with the end in mind. And ideally, we want our test output to read like a high quality report. The test out should be clear documentation of what the functionality actually does. Here's another bad example, because I love coming up with terrible examples. That was kind of fun to put those together. Again, we've got a single test file, test.js. It just says area code, no area code, not enough characters, so on and so forth. At the end of the day, when we read this test output, the only thing we know is that something was tested, but we don't know what it was, and that's no good. A real simple way, honestly, to improve the output is to simply start with some really simple and consistent naming conventions and patterns to follow. Many years ago, when I was doing a lot of C# development, I stumbled across some naming conventions by a guy named Roy Overshore that I've been able to adapt to the Jest and VTest and those kind of JavaScript libraries with a lot of success, I think. So here you can read it more at like the stubbed out level above, but one, have a consistent file naming convention. This is you're probably doing a lot of this already, but it's like an essential step 1, because that gets reported in the test output. And it should follow a kind of a system under test, or whatever your module is, followed by, I'd say test and then .ts or JS or JSX or whatever it is that you're testing. That then can be immediately followed by, a definition of what that test fixture is. And again, that's probably most likely your module name, but that's, again, essential documentation that you can read on your output report. Followed up by whatever the unit of work is, which more often than not is going to be a function that you're testing. The state under test is specifically the input parameters to that, so list those very clearly in your test. And then follow it up with expect whatever the expected result is. And when you do this, here's just an example of it. Again, phone validator.test.ts. We clearly label what the system is that we're testing. We give very specific instructions as to what the inputs are. So given 7-digit number with no area code, very specific here. That actual test code would go inside that commented out test block, followed by a returns, in this case true, because that's what the expected output is. And you can kind of see where it goes from there. Doing this yields much better results. Again, it's a very contrived example, but here's much better output that we can see as a report of, we can clearly see what files are being tested, We see what modules are being tested. We can see the inputs for those. We can see what the expected outputs for those are. Most test frameworks now will even, when the tests fail, report to you specifically, well, here was your input, and here's what we expected to see. So it reads like a very high quality output for a report when things go south. Yeah.
I'm just curious, why don't combine the IT, right, with the describe together, and like given 7-digit number with no area code, return true, and would we have one describe, one level describe, and 3 tests with the IT?
I have found cases where I do that and it makes sense, and I found other times where, as I read the test output, it just, I think, works better to use the describe and say, here are my inputs, and then the expect, the it statement is, here are my expected outputs. So it's how I've worked with the teams I've been on to say, okay, you know, what are we expecting to go into it, and then at the end of it, we expect to get this result. I think so long as the team is consistent and has an understanding about what it is, how everyone does it, that's the main part. And I would encourage everybody, you know, to talk about all of these things with the teams that you work on, because at the end of the day, when everybody does stuff and does these things in a similar manner, everybody wins. Everybody's velocity increases. The code for everybody becomes more readable. So it's just like a win-win-win for everybody. Answering question 5 about how a test can be reproduced can be easily done with another pattern called the arrange, act, assert pattern. Is anyone familiar with that? Got some hands, that's good. So basically, you know, each individual test should have 3 different components. The first one being an arrange section that basically lays out what the requirements for your test are, followed by an act section that performs whatever the action is that you want to test. And then the final section is the assertion part. What do you expect the output to be? If we look at this here, here's just another very contrived example. You know, here we've got a sign up form, and it describes it when the user inputs an invalid phone number, it should disable the sign up button. So we've stubbed out with a comment the arrange part. Notice the comment other test steps. There might be other things you need to do to get your system that's under test into a place where you can do the actual test. It could be sometimes multiple steps. Here's just highlighting, you know, go and get the phone number input. So it goes in testing library again. It'll go find the input with the label phone number attached to it. And then the act portion of that is actually simulating the input of the keystrokes into the input. And then when that's done, you know, assert the find by role button. Go find that button and make sure that it's disabled. I have found on more than one occasion having the actual comments in there, the arrange, the act, the assert comment themselves, and stubbing my tests out ahead of time has helped me reason about and think through how I want to approach writing the test. It's also helped me and other team members catch bugs in our tests where we've looked at it, we've read the test. Because these sections declare the intent, it's really easy then for us to identify, is that really the user experience we want? It doesn't seem like that's what we want. And then it allows us to have that conversation. So thus ends kind of my rant on principle 2. I think there's a lot of good practical information there. At the end of the day, when tests are done right, they're not just a safety net, but the test code itself and the output from it serve as essential documentation. So moving along to number 3, I'm gonna pick on code coverage a little bit more. And just highlight the fact that code coverage is there to serve as, I think, a leading indicator for us if we're meeting our desired goal of the software working as we expect it to. Because if we have automated testing, but we don't have that high level of confidence, especially if we don't have high confidence and we've got that 100% code coverage or whatever, you really got to wonder, what would it say that you're doing here? I mean, really, And it does seem like I'm picking on code coverage, and I totally am, just because oftentimes I feel like we treat code coverage kind of like a vanity metric in a lot of cases. And it can very easily become something that becomes our master. It can become an idol. It's like we just got to get to that code coverage. When in reality, the purpose of the code coverage is to be a tool. It's totally just to be a tool there, and it has a singular purpose. The purpose of it is to reveal to us if there's area of our applications that we should not have high confidence, areas that we're not testing well. So its job is to be a lens into the areas of our code that's about what's being tested. Here's another really contrived example, but it will help illustrate how I found useful code coverage useful in my day-to-day, and that is when I'm daily driving my code, doing development and writing tests, opening up the code coverage reports and having a look at specifically the area of code that I'm looking at. And, maybe I'm working on this fictitious module 1 that's up here, and I thought I wrote all the tests, and I think, hey, everything's working like it should, but I noticed, well, there's a couple branches there that aren't covered. Code coverage-wise, depending on how you're calculating and reporting the metrics, it might look like everything's good because somehow it got through all 100% of the lines of code, but clearly there was something that was overlooked. So being able to drill down into these to see where the system isn't currently being tested. And me personally, I found very unique cases where I found some areas that weren't covered, and I looked at it and I was like, the code here can execute in a way that should not even be possible. And so it was a prompt to me, I'm going to go refactor that to get that part out of it. And again, following some of those cleaner code principles that I showed before, I could just change the implementation, but all the tests still passed because I was testing the user experience and not all of the implementation details. So having that been said, remember that code coverage is there mostly to be a tool to help our developer workflow. And really automated testing is really all about helping our developer workflow because it's there to help us optimize our developer feedback loop. If the desired goal of testing is for us in general to have a high level of confidence that our software is working, then the purpose of automated testing is to increase the speed of the developer feedback loop that we get so we can catch these bugs that could be introduced sooner. So that can lead to a number of ways that we can use it. One, maybe we set these jobs up to run in our CI pipelines. I know we do that and it's great, but then, obviously you might get stuck waiting for that to run on the CI job. And does anyone remember this old XKCD comic? Yes. I have found that this totally applies to testing as well. So maybe it means while you're, daily driving your developer experience testing your code, maybe you want to run those tests locally before you push them up to the CI job because they'll probably run faster locally. You can run just sections of the automated tests ahead of time. That will speed it up. But you still might find cases where the tests are running and you're stuck and you're waiting. And you're like I was a few years ago. It's like waiting like 3 minutes, even locally, for some of the unit testings to run. It's like, well, I might as well make this time useful. So I did a lot of push-ups. It was really good for me. I bring all of this up because even in that case, it was a prompt for me because I'm just sitting here waiting. I need to look and see, well, why is it taking so long for these tests to run? And then spending the time investing in that tooling to increase the developer feedback loop for myself and for my team. In that specific case, it was because the Babel transpiling was taking forever. I think there's much better ways we can do that now. I'm hoping I can live in that future someday. Yeah, Corey?
Bad experiences with code coverage for end-to-end tests, generally for unit tests, it's pretty good. Has that gotten better? Because these bad experiences were probably 110 years ago, and I've just sort of been we don't do code coverage on end-to-end tests. Is that an outdated limiting belief?
don't know, I think it probably depends organization to organization. The policy that we kind of have to us sometimes feels like the Bill Lumberg thing. You know, you got to get to that 90%, and doing unit tests and good integration tests, we found got us a long way, but it didn't get us to that level of confidence that we really desired when we were shipping our software, and so we ended up writing a bunch of Cypress tests to cover broader workflows, and then there's ways you can merge the code coverage from both sets of tools. Both, you know, we were using Jest, but vtest as well. But you can merge those things together to get kind of a better holistic look. Again, I think the idea isn't to look at the code coverage, but to think, okay, you know, do we feel confident based off of the tests that we've written that our software is working as expected? And if you don't feel that way, then invest in the tooling. And the tooling in that case is just spending the time to write the tests that cover the areas that you're not confident about. Does that make sense?
Yeah, so I guess my bad experiences were not so much about like the integration of the code coverage. It was that we had a 3-hour test suite that then we added code coverage, and then we spent 48 hours and we're like, well, it's not done yet. We're just gonna stop.
Oh,
So
because
like
they
we
weren't done
even
executing?
like
Yeah.
it was just like a nightmare. Like it just like system stops like moving forward. We added code coverage. I was wondering if that's improved.
We didn't have a problem adding coverage into our tests from a performance perspective.
On the end-to-end side.
On the end-to-end side, or even on the unit integration side. I mean, it was a little bit slower.
I've never had this problem. It's only on the end-to-end side. Maybe it was because we were using a CAD system. But okay, all right. I will explore this. Thank you.
Yeah, it's a good question, and it touches on the key point here that, you know, we need to invest in making sure that these. Yeah. Oh yeah. That. I don't have the patience to wait for 3 hours for something to run. I really don't.
3 hours was fine. We were okay with that. It was it's not finishing.
That's a lot of push-ups. Exactly. So anyway, just to bring this point home, the automated tests are there to help us, and they're a tool, and as we need to, we should be sharpening that tool. And so just real quick to put a bow on this, the conclusion being, again, the desired outcome for automated testing isn't code coverage. It's to have a high level of confidence that our software is doing what we expect it to do when we ship. And that, you know, we've got these 4 principles that if we follow them and we use these as a lens and a filter through which we interact with the tests that we write and with the conversations we have with our teams, they can help us get to this desired outcome effectively. I've got a QR code for anyone here who wants the slides. It'll take you to my GitHub. Had a lot of good questions so far. Is there any other questions? Yeah, Cass.
When you use some of those like better matchers, like get by role, have you ever run into like timeout issues with your tests? Is that a thing you run into a lot? I tend to run into those as we're just like developing more and more, like making that component more.
I have found flaky tests to be a challenge that need to be handled. And it's been my experience with that. This is like a very much a testing library specific thing, is that there's two matchers you can use. There's the get by matcher, which is synchronous, which will basically, as it gets to that line, it will go and it will execute that matcher and it will go find it right away. But then there's a separate find by matcher that is asynchronous. And if you put a wait in front of it, then it will wait for, I think the Jest or the testing library default is like 1 second. That has been a big part of a solution I found anyway to getting the flaky tests to start passing the way I expect, because there's nothing worse than when you run it locally, and because of the timing of how it runs on your machine, it nearly always passes. But then, you push it to CI, and if your CI pipelines are like the ones I've experienced, the CI pipelines are significantly slower than your local machine, and then your CI builds and your PRs are just failing left, right, and center. And you're like, And if the goal is to have confidence that your stuff is working, there is no confidence in that moment that the changes you made aren't going to break something. And so using the find by was a big part of it. The testing library documentation has a lot of helpful tips on stuff like that. I think also using the like await, wait for is another trick, because a lot of it, when you're testing UIs, goes back to, especially probably because I'm living in a React world, it's like, you know, the action happened, but the DOM hasn't caught up yet. And so if you don't put the proper await step in there, the DOM just hasn't updated yet.
Like we use React Query a lot, so we'll use mock service worker like in the setup, and so you gotta like render the component and then wait. So it always starts with like an await, wait for to get the first bit of markup.
Yep, yeah. So I've had a lot of success with that.
I think my question was, I'm not alone, right?
No, you are not alone. And you know, I felt like on the team I was on a couple of years ago, like we had fixed all of these things, and we fixed like all the flaky tests, and it was working. And then now I'm kind of on a new team, and we're trying to get some of these things going. And now, like as of like the last week and a half, it's like we have CI jobs that are failing, and we also had CI jobs that were updated. Just like the tooling itself was updated. And so, you know, we're constantly seeing PRs fail the CI build, only to go in and look and see, oh, it basically looks like it timed out. And we need to have a closer look at some of the tests that we've been writing to make sure that we're properly awaiting and waiting for UI rendering to happen the right way.